Hi everyone, I am Yogesh Pandey. I have total 11 years of teaching experience and I am MSc B.Ed. Presently I am pursuing my postgraduate diploma in school leadership and management. Today we are going to start with a new topic, and the name of the topic is current electricity. Now in previous classes, in class 9, class 10 also, you all have studied current electricity, so you might have the basic idea of what exactly is the current. Now in the previous two topics, in the first two chapters in class 12, we have studied that the charge, whether it is free charge or it is a, you can say it is a bounded charge, both were at rest. But in this chapter we are going to apply some energy to the charge, and that's why we will move the charge. Okay, the charges will be in motion. So in this topic, that is current electricity, will mostly emphasize on the charges in motion. So let us start with the topic. Now let us study the basic introduction of the topic, and let us see. Now see, this is the conductor. Let us name this conductor as conductor PQ, and you can see now this is a cross sectional diagram of the conductor. So, and you can see the arrows also. Arrows shows the flow of the charge. They are entering at the one end and they are coming out from the other end. Suppose this conductor is attached to the battery, so this will be the flow of electrons. So what are charges? These are actually the electrons which are flowing from, in physics they are flowing from negative to positive terminal, because electrons, they themselves are the negatively charged. So that's why they will always flow towards the other terminal, that is negative to positive. So we can also draw the diagram. Suppose I take the conductor like this, and over here I can connect it like this. Now these are the two ends, suppose A and B. Now earlier the electrons actually they are randomly in the random motion. Okay, I can draw the diagram like this. They are in the random motion when the battery is not attached to them. One small line and one big line. It is the electrical symbol for battery. So this is the battery here, which is having minus and plus terminal. And there are also some fixed ions here. There are small dots over here, and there are fixed positive ions. So there are only two things inside the conductor. One is ions and one is fixed ions, and one is the electrons. Electrons are randomly moving. But when electrons are attached to the battery, what will happen? And if we switch on the battery will supply the energy, and then we will get the diagram like this. We can draw one more diagram over here like this, and again we can attach this to battery. And now in this diagram I can show you the direction of the current, which is the conventional flow, that is from positive to negative. Okay, so what exactly is happening? It is the flow of charge. Flow of charge means in a certain time, and that we are saying it is current. So let us see how the electrons will flow. Then electrons will flow like this, from minus to plus, when we are supplying the current. Okay, and there are also fixed ions in this, with which they collide with each other when the battery is not connected. So that's why they are in the random motion. So they are colliding with two things. These electrons which are inside the conductor in free state, they are in the random motion. They are colliding with two things. One is fixed positive ions, and the other is some other electrons are also there with which they collide. So these are the two things which, and when we are connecting the battery, what will happen? The electron will, since they are negatively charged, so the flow of the electron will be from minus to, or from negative to positive terminal. Okay, and the conventional flow of the current, this is capital I. We do not the electric current symbol by capital I, as you know, you have studied. So it will go from plus to minus. So the flow of current, conventional flow, is always opposite to the flow of electrons. Okay, now let us study this more in detail. Now here I have written this. This is the flow of the current, or we can say these are the electrons which are flowing. So the current flow will be the opposite to it. Now let us see this. Now it is going like this in straight. So they are entering here over at the point P and they are coming out at the point Q. So what is this written here? If capital Q is net charge flowing through normal to cross section, as you know this is a cross sectional conductor diagram. So through normal to cross section of conductor in time t, then current I is given as capital I is equal to capital Q by T. Now what is the SI unit? Now you can say it is coulomb per second. I can also write as capital C and small s, coulomb per second, or it is capital A, that is amperes. So this is the expression which is very important. This is a mathematical formula for current, that is current is equal to rate of flow of charge. Now what is capital Q? Capital Q is the charge. What is the rate? Rate is the time over here. So why we are taking time? Okay, because now here the electrons are flowing. Okay, the current is flowing, that is the charge is flowing. The charge flows in some time. Okay, in a certain time interval the charge is flowing. In a certain time interval the charge is flowing. So in how much time? Suppose we say in 1 second, how much is the charge flowing? Suppose we in 5 seconds, how much the charge has flown? So for that we find the current, because the current itself is known as the rate of flow of charge, and these are the units, that is coulomb per second, or we can write instead of coulomb per second, that is amperes. Okay, so for small currents, or I can say for small amount of currents, we have the units like this. 1 milliamperes is equal to 10 raised to minus 3 amperes. I can write 1 milliamperes is equal to 10 raised to minus 3, because milli means it is minus 3, and 1 microamperes it would be equal to 10 raised to minus 6 amperes. Okay, now let us see something is written on the right hand side also. Now let us see these points one by one. Now let capital I is the symbol of electric current, amperes is flowing through the conductor. Then in 1 second, capital I, that is in coulombs, charge will pass through every cross section. What this means is that if the amount, okay, that is I amount of current is flowing, that is I amperes. Suppose let us take one small example. Let us write over here. Okay, in this much part we will write this. Suppose I amount of current, it is how much? It is 20 amperes. Okay, now I ampere is flowing through the conductor, then in 1 second. So suppose we take the time as 1 second. So what will be here? That means I is equal to capital Q by T. So they are saying that I charge will only pass through the every cross section. That means the charge will also be same, that is 20 divided by 1, and we will get 20 amperes. So if there is I charge, so you will get I amperes only in this formula. So for example, if we take 20 coulomb of charge, let us write the charge also, that is capital Q is equal to 20 coulombs. So it is 20 coulombs per second, that is in 1 second. So how much current we will get? That is 20 amperes. So this is very simple. So both will be same. So whatever charge is there, that much amount we will get in the amperes in the form of current. Now let us see the second point. Charges never accumulate in the conductor. They never get collected at one place. What will happen? They can neither be created nor be destroyed. How you have studied previously in the previous classes in the energy part, that is you know the law of conservation of energy, as energy can neither be created nor be destroyed. Okay, so similarly here also this is one form of energy we are supplying. Okay, that is you can say electrical energy by using the device battery which is supplied, and we are making all the charges which are at rest, we are trying to bring them in motion. So some energy should be supplied to them. In the conductor already the charges are at rest, there are already charges in that. Only thing is we need to activate them, we need to get them into the activation, we need to get them into vibration, we need to get them into the motion. So for that what is required? Energy is required. And what type of energy? Electrical form of energy, and that is supplied by the battery when they are connected in series with the battery, when the whole circuit, electrical circuit is connected with the battery. So the second point is related with that only, that is charges never accumulate in the conductor. They can neither be created nor be destroyed. Hence charge is conserved. So this is the way how charge is conserved. Similarly like energy. Okay. So let us see. Suppose this is an amount of the charges are flowing at the P end in the cross section of the conductor. So the same amount of charge it will come out. Okay, from the other end also. They will never stay in one position. They will never accumulate, or they will never get collected inside the conductor, and they can neither be destroyed also, and they can neither be created nor be destroyed. You cannot create also the charges, and you cannot destroy also, and this is the way how charge is conserved. Now let us see the third point. Now the direction is always in opposite direction to electrons. This charge, the direction of charge means the direction of current. Whenever we talk about charge means it is the amount of charge per unit time. So that is charge, that is we have written that it is, the unit is coulomb per second. So coulomb unit, the SI unit of charge is coulomb. So if I want to write over here, again I will write capital I is equal to capital Q upon T. What is the Q? Q is the charge. This is the charge. And what is the unit of charge? Unit of charge is in coulombs, and unit of time is in seconds. So here they are saying that the direction of the charge, its direction means the direction of charge, or I can say direction of flow of current, it is always in opposite direction of electrons, which is the conventional flow. So this direction of current, suppose the electrons flow always from negative to positive terminal in the battery. So the charges or the current will flow from positive to negative terminal. Now let us see one example over here. Again, let us make one diagram, small diagram here. Now this is the conductor, which is AB. Now this conductor is connected to the battery over here. Let us put one key also. Okay, that is a plug key. Now the plug key is on, so the current will start flowing from plus to minus. We know this much. We have studied in the 9th standard onwards. We have studied like this. Now this is a conductor AB. Now what is happening here is, when the current is flowing like this, so the electric field is in this direction. This is the direction of electric field. Okay. Now what is inside the conductor AB? We know that the conductor has electrons. All free electrons are there, which are in random motion when the battery is not connected between them. So this, they are negatively charged. They will get attracted to the opposite end. Okay, this end where the plus sign is there. So what will happen? The electron will start moving like this. They will start flowing like this. Okay, and they are also negatively charged. So this is the flow of electrons. Now electrons are moving from this end like this. Okay, and when they will come at this terminal, that is minus, so what will happen? Repulsion will take place between the two negative charges, the flow of electrons and this negative charge of the battery. So minus minus, and when repulsion takes place, again they will get drifted away from here, and again the flow of electrons will be continued like this. So this is the flow of the electrons. But see the flow of the electric field. Electric field means this is known as the conventional flow of the current. Conventional flow of current, and which is from positive to negative terminal. And see how I have explained you the flow of electrons. Now there are electrons, they will get attracted towards the positive end. So that's why they will flow like this. Okay, so they are flowing actually from negative to positive. So that's why in the books it is mentioned that they flow from negative to positive. But this is the main reason, because they are negatively charged and they get attracted towards the positive side, or towards the positive terminal of the battery. Okay, so they flow like this, and when they come at the minus terminal, that is negative terminal, so negative charge of the electron and negative charge of the battery both will repel each other, and due to this the direction of the electrons, it will continue to be same, because there is a repulsion. So again they will go away from this, and so this direction it is joined together, and since we can say that, and hence we can say that the electrons flow from negative to positive terminal. So the flow of the current is opposite to the flow of the, now see, this is the negative means the electrons are flowing like this. So this is the flow of electron. Now, so what is the flow of electric current? It will be opposite to it. So the electric current will flow like this. You can see the direction of electric field. So this is the flow of electric current. So I can write this is the flow of electric current, that is capital I. Okay. Now let us try to understand one more example from this only. Suppose here there are two plates here, which is having plus sign, and here also it is having minus sign. And suppose we keep something in between. Let us keep some blocks in between which are having electrons here. Now these are electrons here on these blocks. Let us say they are of the metal, okay, and they are having electrons on it. So what will happen in this? These electrons, since they are negatively charged, they are having which charge? Electrons are having negative charge. So negatively charged electrons, they will again start getting attracted to the positive plate. All the electrons, they will get attracted towards this. So what happened now? All the electrons have come here. Okay, all the electrons which were there are 5 electrons. Suppose we take 5 electrons, have accumulated at the positive charge. So this space, it will become vacant after some time. Once all the electrons get attracted towards the positive terminal, this space will get vacant. Now see, the electrons are coming in this direction, that is left side direction. Okay, and the space is becoming vacant from this direction. When all the electrons are coming in this direction, the space is becoming vacant in the right hand side direction. Okay, towards negative. So what happens? So the space is being vacant. So this is the direction of conventional flow of electric current. This is the direction of conventional flow of electric current, that is capital I. Okay, because we know that the direction of conventional flow of electric current is from positive to negative terminal. Now see, the electrons have moved from where? Negative to positive, because they are negatively charged itself. So obviously they will go to the opposite terminal. Okay, and where the seat is getting vacant, it is getting from left hand side, it is starting and it is going till the right hand side. So what is happening? The conventional flow of electric current, this is the direction where the seats are getting vacant. Okay, so we can say it is going from plus to minus. Seats means these were the positions, okay, of the objects which were having the electrons on them. So once they have become vacant, so now there is nothing. So these spaces are becoming vacant in this direction, right hand side direction, and that direction is the direction of conventional flow of electric current. Now let us try to understand the next point. In some cases, when net flow of charge is not steady, means the net flow of charge is always changing per second. So that time what happens? Then average current will be given by which formula or by which equation? So average current is equal to I average is equal to change in charge upon change in time, that is delta Q by delta T. And for instantaneous current, we write this, we try to find the limit. You have studied in maths, that is capital I is equal to limits of delta T tending to 0 for very small time interval. Okay, very small time interval, that is delta T tending to 0, because it is going towards 0. Delta Q, so we will find the limit of the same formula, that is limit of delta T tending to 0 or to of delta Q by delta T. So what we will get? I is equal to change in charge upon change in time, that is dq by dt. So now we have the equation. Let us take one equation, that is capital Q, okay, is equal to 2t square plus 3t plus 1. Okay, and here we have the current for time from time t is equal to 0 seconds to t is equal to 1 second. So what we will get? I is equal to delta Q by delta T is equal to QF minus QI upon TF minus TI. Now what is QF? QF is the final charge minus QI is the initial charge. Okay, so final charge means it will be for the time 1 second, and initial charge it will be for the time 0 seconds, and TF will be the final time minus initial time. Okay, so let us solve over here.